Hi. I am Ms. Lyra C. Bitayo, your digital teacher for today. In this video, we will share new learnings in general mathematics. So let's get started. Once again, here is our most essential learning competency for this week. Accurately construct mathematical models to represent real-life situations using functions. And for today, we are going to focus on Lesson 1.3, Operations of Functions, specifically to perform addition, subtraction, multiplication, division, and composition of functions. Before that, let's have a review first on operations of fractions and rational expressions. In your junior high school mathematics, you learned about the fundamental operations of fractions and algebraic expressions. Mastery of this concept and skill would make learning about the operations of functions easy. The following are the steps in performing addition and subtraction of fractions and rational algebraic expressions. First, find the least common denominator, LCD, of the fractions. Second, rewrite the fractions as equivalent fractions with the same LCD. If the fractions have the same denominator, skip steps 1 and 2. Third, the sum or difference of the numerators in the numerator of the resulting fraction. The LCD will be the denominator of the resulting fraction. Example. Find the sum of 1/3 and 2/5. Solution. The LCD of the fractions is 15. After finding the LCD, rewrite the fractions to similar fractions using the LCD, so we have 5/15 plus 6/15. Then, combine the numerator. 5 plus 6 is equal to 11. Therefore, 1/3 plus 2/5 equals 11/15. Another example. Find the difference between 1 over x minus 3 and 2 over x minus 5. Solution. The LCD of the fractions is the product of the denominators, x minus 3 and x minus 5, or simply, x squared minus 8x plus 15. Then, rewrite the fractions to similar fractions using the LCD. We have x minus 5 over x squared minus 8x plus 15, minus 2 times the quantity of x minus 3 over x squared minus 8x plus 15. Next, combine the numerator. X minus 5, minus the difference of 2x and 6. So, x minus 5 minus 2x plus 6. Therefore, 1 over x minus 3, and 2 over x minus 5 equals negative x plus 1, over x squared minus 8x plus 15. Now, let us proceed with the steps in performing multiplication of fractions and rational algebraic expressions. First, rewrite the numerator and denominator in terms of its prime factors. Second, common factors in the numerator and denominator can be divided out. Third, multiply the numerators together to get the new numerator. Fourth, multiply the denominators together to get the new numerator. Example. Find the product of 10/21 and 15/8. Solution. Express the numerators and denominators of the fractions into their prime factors. We have 2 times 5 over 3 times 7 times 3 times 5 over 2 times 2 times 2. Next, divide the common factors. 2 divided by 2 is 1, and 3 divided by 3 is 1. Then, multiply the remaining factors in the numerator and in the denominator. 5 times 5 is 25, and 7 times 2 times 2 is 28. Therefore, 10/21 times 15/8 is 25/28. Another example. Find the product of x squared minus 4x minus 5 over x squared minus 3x plus 2 and x squared minus 5x plus 6 over x squared minus 3x minus 10. Solution. Express the numerators and denominators of the fractions into their prime factors. So, we have x plus 1 and x minus 5 over x minus 2 and x minus 1 times x minus 2 and x minus 3 over x minus 5 and x plus 2. Next, divide the common factors. We have x minus 5 and x minus 2 as common factors. Then multiply the remaining factors using FOIL method. The quantity of x plus 1 times the quantity of x minus 3 is x squared minus 2x minus 3. And the quantity of x minus 1 times the quantity of x plus 2 is x squared plus x minus 2. Therefore, the product of x squared minus 4x minus 5 over x squared minus 3x plus 2 and x squared minus 5x plus 6 over x squared minus 3x minus 10 is x squared minus 2x minus 3 over x squared plus x minus 2. Lastly, we have here the steps in performing division of fractions and rational algebraic expressions. First, get the reciprocal of the divisor. Then, proceed with the multiplication of fractions and rational expressions. Second, rewrite the numerator and denominator in terms of its prime factors. Third, common factors in the numerator and denominator can be divided out. Fourth, multiply the numerators together to get the new numerator. And multiply the denominators together to get the new denominator. Example. Find the quotient of 10/21 and 15/8. Solution. Get the reciprocal of the divisor. The reciprocal of 15/8 is 8/15. Now we have 10/21 times 8/15. Next, rewrite the numerator and denominator in terms of its prime factors. Thus, 2 times 5 over 3 times 7 times 2 times 2 times 2 over 3 times 5. Divide the common factors. Then proceed to multiplying the remaining factors in the numerator and in the denominator. So 2 times 2 times 2 times 2 is 16, and 3 times 7 times 3 is 63. Hence, the quotient of 10/21 and 15/8 is 16/63. Last example. Find the quotient of 2x squared plus x minus 6 over 2x squared plus 7x plus 5 and x squared minus 2x minus 8 over 2x squared minus 3x minus 20. Solution. Get the reciprocal of the divisor. The reciprocal of the divisor is 2x squared minus 3x minus 20 over x squared minus 2x minus 8. Express the numerators and denominators into factored form. Now we have 2x minus 3 and x plus 2 over 2x plus 5 and x plus 1 times x minus 4 and 2x plus 5 over x plus 2 and x minus 4. Next, divide the common factors. Therefore, quotient of 2x squared plus x minus 6 over 2x squared plus 7x plus 5 and x squared minus 2x minus 8 over 2x squared minus 3x minus 20 is 2x minus 3 over x plus 1. Let us proceed. In Module 1 Week 1 Lesson 1.2, you have been taught on how to evaluate a function by replacing the variable with a value from the function's domain and computing for the result. That concept served as your foundation in performing different operations of functions. Now, let's have an activity. The title of this activity is, Can you solve me? In this activity, you need to perform the operations of the functions indicated. Number 1. If f of x equals 2x squared plus 2x and g of x equals 2x minus 1, what is the f plus g of x? A. 2x squared plus 4x minus 1. B. 2x squared minus 1. C. 6x squared minus 1. D. 2x squared plus 4x minus 1. You have 10 seconds to answer. The answer is letter D, 2x squared plus 4x minus 1. Number 2. If y equals 2a over 3 and z equals 7a over 3, what is z minus y? A. 5a over 6. B 5a over 3. C negative 5a over 3. D negative 5a over 6. You have 10 seconds to answer. The answer is letter B 5a over 3. Number 3. If A equals 2x plus 5 and B equals 5x, what is A times B? A. 10x plus 5. B. 10x squared plus 10x. C. 10x squared plus 25x. D. 10x squared plus 10. You have 10 seconds to answer. The answer is letter C, 10x squared plus 25x. Number 4. If m equals k squared minus 1 and n equals k plus a, what is m over n? A. K squared minus 1 over k plus 1. B. K minus 1. C. K plus 1. D. K. You have 10 seconds to answer. The answer is letter B, k minus 1. Number 5. If y equals 5a and a equals 2x plus 1, what is y in terms of a? A. 10x plus 1. B. 2x plus 10. C. 10x plus 5. D. 10x. You have 10 seconds to answer. The answer is letter C, 10x plus 5. What you did in the previous activity is a glimpse of how the operations of functions work. To formalize what the operations of functions are, the definition is reflected below. Definition. Let f and g be functions. A. Their sum, denoted by f plus g, is the function defined by f plus g of x equals f of x plus g of x. B. Their difference, denoted by f minus g, is the function defined by f minus g of x equals f of x minus g of x. C. Their product, denoted by f times g, is the function defined by f times g of x equals f of x times g of x. D. Their product, denoted by f divided by g, is the function defined by f divided by g of x equals f of x divided by g of x, excluding the values of x where g of x is 0. The important concept of this lesson is that addition, subtraction, and multiplication of two or more functions together will result in another function. The division of two functions together will also result in another function if the denominator or divisor is not zero function. Examples. Given the following functions. F of x equals x plus 3. P of x equals 2x minus 7. V of x equals x squared plus 5x plus 4. G of x equals x squared plus 2x minus 8. T of x equals x minus 2 over x plus 3. Find A. V plus g of x. B. F times p of x. C. P minus f of x. D. V divided by g of x. Solution. A. What is the sum of functions v and g? V plus g of x equals v of x plus g of x. By definition, v of x is x squared plus 5x plus 4, and g of x is x squared plus 2x minus 8. Substitute v of x and g of x. Add the two functions by combining similar terms. We have x squared plus 5x plus 2x plus 4 minus 8. X squared plus x squared is 2x squared, 5x plus 2x is 7x, and 4 minus 8 is negative 4. Therefore, the sum of functions v and g is 2x squared plus 7x minus 4. Let's proceed to letter B, and that is to solve for the product of functions f and p. F times p of x equals f of x times p of x, by definition. Next, substitute f of x and p of x. We have here f of x is x plus 3, and p of x is 2x minus 7. Then, multiply the two binomials. Using FOIL method, x times 2x is 2x squared. X times negative 7 is negative 7x, 3 times 2x is 6x, and 3 times negative 7 is negative 21. Now, combine like terms, negative 7x and 6x is negative x. Thus, f times p of x equals 2x squared minus x minus 21. Letter C, we have here the difference of functions p and f. P minus f of x equals p of x minus f of x. Substitute p of x and f of x. P of x is 2x minus 7, and f of x is x plus 3. So, 2x minus 7 minus x minus 3. Therefore, p minus f of x is x minus 10. Letter D, v over g of x equals v of x over g of x. Substitute v of x and g of x. Then, we have x squared plus 5x plus 4 over x squared plus 2x minus 8. Express into factor form. X squared plus 5x plus 4 is x plus 4 and x plus 1, while x squared plus 2x minus 8 is x plus 4 and x minus 2. Then divide the common factors. X plus 4 divided by x plus 4 is 1. Thus, the quotient of functions v and g of x is x plus 1 over x minus 2. Now that we have solved the sum, difference, product and quotient of the functions, let us see their graphs using Desmos graphing calculator. Desmos is a free online graphing calculator that let users explore math in new and exciting ways. Desmos wants to help every student learn math and love learning math. Graph functions, plot tables of data, evaluate equations, explore transformations, and much more for free. First, we have the sum of functions v and g of x, 2x squared plus 7x minus 4. By using the graphing calculator, simply type the function, and note that we will represent v plus g of x by y, since Desmos graphing calculator only support implicit equations of x and y. So, we have y equals 2x squared plus 7x minus 4. And that's it. We have here the product of function p and f of x, which is 2x squared minus x minus 21. Graphing time. And in a second, we have the graph. We have here the difference of function p and f of x, which is x minus 10. Graphing time. Then, we have the graph. And last one, we have the quotient of function v and g of x, which is x plus 1 divided by x minus 2. Let's graph using Desmos. Then, there's the graph. The composite function, denoted by f is composed of g is defined by f is composed of g of x equals f of g of x. The process of obtaining a composite function is called function composition. Examples. Given the following functions, solve the following. F of x equals 2x plus 1. Q of x equals x squared plus 2x plus 2. And g of x equals square root of x plus 1. 1. What is g of f of x? Solution. G is composed of f of x is equal to g of f of x, by definition. Next is to substitute f of x to the x of g of x. Since g of x is equal to square root of x plus 1, substitute 2x plus 1 to function g's x. Then we have square root of 2x plus 1 plus 1. Thus, g of f of x is square root of 2x plus 2. 2. Find and simplify composite function f and q. Solution. F is composed of q of x, or f of q of x, by definition. Then substitute q of x to the x of f of x. So 2, q of x, plus 1. Then 2, x squared plus 2x plus 2, plus 1. Thus, f of q of x is 2x squared plus 4x plus 5. 3. What is composite function of q and g of 3? Solution. G is composed of f of 3 equals g of f of 3. Q is composed of g of 3 is q of g of 3. By definition. Then substitute 3 first to the x of g of x, and next will be q of x. So q of g of 3. Since g of x is square root of x plus 1, we have here g of square root of 3 plus 1. 3 plus 1 is 4. Hence, square root of 4 is 2. Now we have q of 2. Next is to substitute 2 to q of x. So 2 squared plus 2 times 2 plus 2 is equal to 10. Thus, q of g of 3 is 10. Now it's your time to answer. Test A. Perform what is being asked. Given f of x equals 2x plus 1, g of x equals x squared minus 2x plus 2, and r of x equals 2x plus 1 over x minus 1. Find 1. F plus g of x. 2. G minus f of x. 3. F times r of x. 4. G over f of x. 5. F over r of x. 6. F times g of 1. You have 5 minutes to answer. Test B. If f of x equals x squared plus 3x and g of x equals x minus 2, find and simplify the following composite functions. 1. F of g of x. 2. G of f of x. 3. F of x. 4. G of x. Another 5 minutes to answer. Test C. Each pair of functions below have a special relationship, because f of g of x equals x, and g of f of x equals x. Verify these. 1. F of x equals 3x minus 2, and g of x equals 1/3 of x plus 2. 2. F of x equals x over 2 minus x, and g of x equals 2x over x plus 1. Complete the sentence/formula based on your understanding of the lesson. For operations of functions, we let f and g be functions. There are 4 operations, namely addition, subtraction, multiplication, and division. Let's start first with addition. A. Their sum is the function defined by what? Okay. The quantity of f plus g of x equals f of x plus g of x. B. Their difference is the function defined by what? Good. The quantity of f minus g of x equals f of x minus g of x. C. Their product is the function defined by what? Correct. The quantity of f times g of x equals f of x times g of x. D. Their quotient is the function defined by what? Nice. The quantity of f over g of x equals f of x over g of x. Next, composition of functions. The composite function is defined by what? Very good. It is defined by f is composed of g of x equals f of g of x, where the process of obtaining a composite functions is called function composition. Now, let's have the application. And it is for you again to answer. Ready? Okay. Determine 2 real-life situations that can be represented using functions. Task 1. Draw the table of values for each situation. Task 2. Look into the relationship between the values of the independent and the dependent variable in the situation. Task 3. Represent the situation as a function. Let the function for the first situation be f of x, and the second be g of x. Then, regardless of what the functions represent, use these functions and perform the following operations. 1. G of x plus f of x. 2. F of x minus g of x. 3. F of x times g of x. 4. F squared over g of x. 5. F of g of x. 6. G of f of x. 7. G of x over f of x.